We call them as iterative statements, or we can also call them as looping statements. So what does this iterative statements actually mean? Okay, an iteration statement or a loop, it repeatedly executes a statement known as the body of the loop until the controlling expression is false. That means I have a body that I call it as a loop body. So whenever I have a body, I'll represent the body as it as a block. That means in between the opening and closing parenthesis. In between the opening and closing parenthesis, this I call it as a block, or I call it as a body. So in iterative statements, so I'll be executing this body repeatedly. Repeatedly, I'll be executing the body until the controlling expression. So this is controlled with the help of one expression until this expression is false. That means if the expression value is true, I will be executing this body, this loop, this block. If that expression value is false, I will not execute this body. So I'll be repeatedly executing this body, only these statements. So inside this body, I can write any number of statements as I wish. I can write 3, I can write 10, I can write 20, any number of statements as per my choice. Okay, an iteration statement or a looping statement, it repeatedly execute the statements. Known, these statements are known as loop body until the controlling expression is false. So until it becomes false, I'll execute it. So that means when I'll execute it, I'll execute when it is true, and I'll stop when it becomes false. So this is the basic idea of writing an iterative statements. So when I'll write these kind of statements is, suppose let us say I have five instructions. Five instructions I have. So where I want to execute those five instructions, let us say for 5 times. The same five instructions for 5 times. So I can write those five instructions inside a block, and I'll create a test expression such that this test expression holds true for 5 times. This test expression, it holds true for 5 times. So I can execute this body for 5 times. This loop body can execute it for 5 times. So this is what the basic idea of an iterative statements. Okay. So as you see on the screen, so you have two types of these iterative statements. So what are those two types of iterative statements are? Entry control and exit control. Entry control and exit control. So what is entry control and what is exit control? So as a name, you can identify what it actually means. So you'll be controlling whether to execute this loop body for the next time. The controlling expression is returned, or the controlling expression is verified at the entry point. If the controlling expression is verified at the entry point, I call it as an entry control. I'm controlling the entry level. I'm controlling it at the entry level. If the controlling expression is true, I will execute the loop body. If the controlling expression is false, I will not execute the loop body. That means I am controlling whether to execute the body or not at the entry level. That is called as entry control iterative statements. Exit control. So what do you mean by exit control?
What, sir?
What do you mean by exit control? The controlling expression is verified at the exit level. So when I write a
Move from the
when
deep.
when I write a body like this or a block like this, so this is my entry level, this is the exit level, right? So this is a beginning, this is a beginning, and this is the ending. So beginning is a entry level, ending is the exit level. So where you can write your control expression in either at the beginning or at the ending. If you write the control expression at the entry level, I will call it as an entry control loop. Okay. If the controlling expression is written at the ending, that I call it as an exit control. So you got a basic idea what is meant by an iterative statement? Yes or no?
Yes, sir.
Yes.
So we'll see. So this is the flow chart for your entry control and exit control. Okay, so you can look first. We'll look at the entry control. See, in the entry control, it enters like this. The control enters like this. So it verifies the condition. I'll be writing the test expression or controlling expression or test condition. You can call anything. Okay, I have a condition here. So with this condition, so this condition may be true or false. If this condition is true, it executes the body, which I call it as a loop body. So this loop body can be of any number of statements as per my task. As per the task, it may be 1 or it may be 10 or any number of statements you can write. So this body is executed when your test condition is true. So after executing the body again, it goes back and again it verifies the condition. That means body is already executed once. And after executing the body again, it goes back and re-verify your test condition. It will re-verify the test condition. So when it is verifying the test condition, again the condition may be true or false. If this condition is true, again it will execute the same body. So this will be repeatedly executed and condition is verified until your condition is true. So once if your condition becomes false, so without executing the body, it comes like this. So when the condition becomes false, it will not execute. So whereas in the if statements, so there also we are verifying the condition, right? If the condition is true, you are executing in this way, and when the condition is false, you are executing in this way, and you are continuing in this way. You are not going back to the condition. In if or if else statements, so you are not going back. Whereas in the iterative statements or looping statements, so here I'll be forming a loop here. So this I call it as a loop. So the statements are executed repeatedly. So for that repeated procedure, it should stop at some point. So to stop that execution at one point of time, I am writing a test condition there. I am writing a test condition. So based on that test condition, I can judge whether to execute the body or not to execute the body. So is it clear with the entry control? So where I'm verifying the condition is before executing the body, I'm verifying the condition. So I call it as an entry control. Got it?
Yes, sir.
So you can see the figure, the flowchart, which is on the right side. So which is exit control. So whereas in the exit control, first I will execute the body. That means the statements which I want to execute, first I'll execute them. So after completing that execution, then I will be verifying the test condition. Then I'll be verifying the test condition. So when I verify this condition, again it may be true or false. If this condition is true, I will go back and re-execute my body. I will go back and re-execute the body. So after completion of the body, again I'll verify. That means for the very first time, I will not verify any condition for executing the body. From the second time onwards, whether to re-execute or not, it depends on the condition I have written here. Clear? Whereas in the entry control, the first time is also restricted. The first time is also dependent on the condition. The first execution of the body itself is dependent on the condition. Maybe the condition which I have written may be false for the very first time. I don't know whether it is true or false. It might be true, it might be false. Maybe the condition which I have written there, it may be false for the very first time. So I can't execute the body there. But whereas in the exit control, irrespective of the condition you write, you execute the body for the first time. You execute the body for the first time. From the second execution onwards, it depends on the condition which I write there, whether to execute the same body for the second time or not. So that is dependent on the condition which I write there. Okay, if it is true, it goes back and re-execute the body. If it is false, it comes out of your body. Clear?
Yes, sir.
Sir, what did you told?
What?
Sir, what did you told?
What is the hello? Hello?
Hello?
What you're asking something?
Sir, can you repeat again?
What to repeat? Entry control or exit control?
Sir, both.
Why both? Okay. So in the entry control, we have to execute the body. So before executing the body, we'll verify the condition. First, the condition is verified. If the condition is true, then it executes the body. and after executing the body, it goes back and re-verify the condition. So here, whether to execute the body or not is dependent on the condition which is verified before the body. Before executing the body, that is verified. That is called as entry control. Okay. Coming to exit control. So in exit control, you'll control here, but the condition which you control is at the exit level. So that means first I will be executing the body first, and after completion of the body execution, then I will go and verify the condition. That is my test expression. So test expression is verified after executing the body. So if the condition is true, it goes back and re-execute your body. Otherwise, if the condition is false, it simply comes out of the body. That means it will not re-execute the body. That is exit control. Here, the controlling point is at the exit level. The controlling point is at the exit level. Whereas in entry control, the controlling point is at the entry level of the body. Okay, so this has entry control and exit control. So now we'll see what are the different structures which support this entry control and exit control. So first I'll start with the while loop. So which is an example for entry control. Example for entry control. So when we are writing this while loop, we use a keyword called while. The keyword is while, and here I'll write a test expression is written. So remember, the test expression is written in between these brackets, and test expression is written with. So how we'll write the test expressions? So test conditions or test expressions are always written with what operators? So what operators are used in writing the test expressions or test conditions?
One.
What? What operators we use in writing the test expressions?
Relational.
Relational or logical operators. Okay, so I'll use a keyword called while, and I'll write a test expression in between the brackets, and I have a pair of this opening and closing flower braces. So the statements which are written in between these 2 points are called as loop body, or we call it as a body of the loop. Okay, so the statements which are written inside this are called as a body of the loop. That means in between the opening and closing parenthesis. So this is how we'll write a simple while structure. That means if we want to repeat a particular set of statements, so that particular statements can be written in between these 2 points, and that is written in a while loop. Okay, so you can look at this flow chart here. So this is the same as the flow chart of your entry control. So you will write a test expression. If the test expression is true, it execute the while loop body. That means the statements which are written in the inside the block. And after completion of this body, it will again re-verify your test expression. If this is true, again it will repeatedly do this procedure. If this test expression becomes false, it comes in this way. Okay, so first it verifies your test expression you write here. If this test expression is true, it execute all the statements which are inside this body, and after completion of this body, again it goes back and re-verify the test expression. Okay, again if it is true, again it will repeat the same body for the next time, and again it goes back and verify the test expression. If this becomes false, it comes out of the statements. That means the statements which are written after this while loop. Got it? So this is the simple uh,
Yes, sir.
body of how to write a while loop. So I'll tell you with an example now. Okay, we'll see with a simple example. Hash include stdio.h. We'll start with void main. Okay. Let us say I have a statement here. I want to print a statement like this. Say, suppose this is my statement I want to print. Okay. Okay. If I have this statement and I want to print this statement for one time. So how will you print? I want to display this statement for one time on the screen. So what we will do? Hello. So how to display this statement on your screen? If you want to display this statement on your screen, so what you will do? So will you get this statement on the screen or not? We'll get this statement on the
Yes,
screen,
sir.
right?
We get.
See, I'm just compiling it. So this is what I got on my screen. Suppose if I want to display this statement for 5 times. I want to
Like printf, printf, printf,
write
printf.
printf for how many times you write it?
5 times.
5 times is fine, right? So I'll simply written it for 5 times. So I got this statement for 5 times, right? Clear? I want to display this statement for 50 times. I want to display this statement for 500 times. So what you'll do? Hello? Hello? Am I audible? So suppose if I want to display
Yes,
the
sir.
same statement for 500 times, so is it possible to write it for the same statement for 500 times, like simply copy paste, copy paste? Yes, it works out, but that is not the proper sense. The same question if I ask to display the same statement for 5,000 times, the same statement I want to display. Okay, so when you have one task to do repeatedly for number of times.
Yes, sir.
Hello? Yes, what you want?
Hello.
Yes, Swarup, tell me. Any doubt?
You have any doubts, you can express it.
Yes, sir.
Oh, then.
No, sir. No doubt. Sir, what
So
is the full form of
it is
stdio dot
standard
h?
input output.
Standard input output.
Okay, sir. Sir, what is dot h?
That means header file.
Sir, what is dot
It
h?
means header file. And we are discussing something other
Okay, sir.
than that. That is not the point of our discussion. If you have that, you can ask it later, not in the middle of discussing something. If you have doubt anything related to what we are discussing, that goes fine, right? At stdio.h means a standard input output. .h indicates that it is a header file. So for every file, we'll have some extension. Like when we write a C programming file, we'll write it as .c. We'll write a document file, we'll write it as .doc, .pdf. So like every file will have some extensions. So okay, so suppose if you have one task, so which here the task is to display one particular statement, and I want to display the same statement for number of times. Say it is for 5 times or 10 times, you can copy paste, that goes fine. But the same statement if I want to display for 500 times or 5,000 times, so that doesn't make any sense if I copy paste it for 5,000 times. Okay, so for that kind of scenarios, we have these looping statements. So these looping statements, suppose what statements I want to execute repeatedly. I want to repeatedly execute one printf, right? One printf I want to execute it for 500 times. So only one statement here, right? Hi students, welcome to class. So that is one statement where I want to repeatedly execute that one statement for these many number of times.
Our voice is breaking.
Okay. So I want to execute the same statement for number of times like this. So say it as a 500, 5,000, 1,000, many times repeatedly. So for that kind of scenarios, we have these looping statements. So what I'll do is I'll consider one statement. I'll consider this one statement and I'll place this statement inside a block. I'll place this statement inside a block and I will make this block to execute for 500 times. I'll make it execute for 500 times. So how I'll write? While. So here I will write one test condition which holds true for 500 times. Which holds true for 500 times. And after 500, that means if it becomes 501, I will make it as false. So that means I have to design one test condition such that that test condition should hold true for 500 times only. So my desired number is 500. If my desired number is 100, I will make it for 100 times. Okay. So for that, see how we'll write it. So I'll take two variables for managing this loop. I'm sorry. Yes. So I'll manage my loop. So with the help of these two variables. So one is my starting point and 100 is my last point. That means I want to execute this statement for 100 times. Say I want to display it for 100 times. I'll repeat it for 100 times. So if you want it 500 times, you can take this n as 500. So I'm just taking it as 100. Okay. So I will write a test condition which holds true for 100 times in this example. So how I'll write I less than or equal to 100. So what is the value of I?
Hundred.
What is the value of I?
Hundred.
Hey, you can see there. Huh?
Can you repeat again?
What is the value of I there?
One.
100.
How can you say it 100? Is it you know numbers or not?
1 to 100.
What is the value of I written there? I equal to
One.
1. How you are saying 100? The value of I is written there as 1. N value is 100. Okay. See, it is visible on the screen clearly, right? I value is 1 and N value is 100. So my starting point, I am taking I value as 1 and my target is 100 here. Okay. So first I'll verify this condition. One less than or equal to 100. Someone please mute your mic. It is disturbing. So 1 less than or equal to 100. Is it true or false?
True, sir.
True. 2 less than or equal to 100.
True.
3.
True.
So every time it is true here, right?
Yes, sir.
Yes, it goes on like 40 less than or equal to 100.
True.
So in between all the numbers here, right?
Yeah.
99 less than or equal to 100.
True.
100 less than or equal to 100.
True.
Still it is true. And after that it becomes 101. 101 less than or equal to 100.
False.
False. So how many times it is true here?
100 times.
100 times. So I can iterate this loop for 100 times. So by simply after printing every time, I'll increment my I value. So initially it is 1. Initially I have taken the value of I as 1. So after it is true, when this condition becomes true, I will go and display this statement on the screen. I'll go and display that statement by using that printf. It displays that statement on the screen, and then I'm incrementing the value of I with 1. I plus plus means it increments by 1, right? So then I becomes
2.
2. And next time when you are verifying this condition, so this time you are verifying not with 1, you are verifying with
2.
2 less than or equal to 100. Still it is true. I'll display that statement on the screen and I'll increment I value. So this time I becomes 3, 4, 5. So like that, every time it increments I value, it verifies the condition whether it satisfies or not. That means whether it is holds true or not. If it holds true, it displays the statement and increment. When I value is equal to 100, 100 less than or equal to 100, it verifies. Yes, it is true. That means this statement is displayed for 100th time, and after displaying it for 100th time, again you are incrementing your I, it becomes 101. Then it verifies 101 less than or equal to 100. So this time it fails because 101 is not less than or not equal to 100. So this condition becomes
False.
false. So it will stop executing the body anymore, and simply it comes out of your body. So where is the body here? Body is in between these two points. So it comes out of the body. So it will no more execute the body. So clear? So I'll show you an execution. See, the same statement got displayed for 100 times. So if you have still doubt, I can just display the value of I here. Percentile D. I'll display the value of I. So every time it displays the number and it displays the statement. See, at the last 100th time. Okay. So 199 and like this, it starts with 1 in the first time. So every time it is displaying the number with the
Can you
statement.
show the code?
Yes. This is the code. So I have written the statement which I want to display only for one time. Simple. If I want to repeat the same for 500 times, instead of 100, I'll make it as 500. You no need to take it this n also. Remove this n here as well. You are just writing I less than or equal to 500. That is enough. So the same statement. So this statement will be displayed for 500 times now. See, the last time is 500th time. Clear?
Yes, sir.
So this is how you can write your looping statements. Okay. So is this example clear?
Yes, sir.
Okay, fine. So now we'll see.
When I show the code again, I was disconnected.
What?
For the code again, I was disconnected.
This code. So you can check it later. Okay. I'll tell you one more example. So you try to understand this one. So it would be easy for you to compare when you look the same example again. Okay. So you just try to understand this example now. So it would be easy for you. Okay. See, suppose I want to find out the sum of first n natural numbers. Suppose if the value of n is a 10, if the value of n is given as 10, I will try to find out the values from 1 to 10, the sum of the values from 1 to 10. That means 1 plus 2 plus 3 plus 4 plus 5 plus 10 up to 10. Okay. See what I'll do. So I will take a variable called I, so which starts with 1. So this is the starting number. So from 1 to 10. If n is 10, it is 10. If n is 20, if it is 1 to 20. If n is 50, 1 to 50, like that. Okay. So first what I'll do is I'll take a variable called I, which starts with 1, and I'll take one variable called sum. So here I'll have the result. Okay. So in this sum, I will initialize this sum value with 0. Okay. I'm not telling any code now. I'm just telling you the logic how we can implement. Okay. I'll take a variable called sum, which is initially 0. Okay. So now what I'll do is I will add every number. That means 1 plus 2 plus 3 plus 4. Every number I will add it to this sum. Okay. So before adding that number to sum, I will verify with one condition. I will verify with one condition. Let us not take this n as 10. We'll take a small number. Let us take it as a 5. So we can easily we can conclude it. Okay. So see, can I add the value of I to sum? So my task is to add all the numbers between 1 to 5 here, right? Yes or no? To add all the numbers in between 1 to 5. Hello?
Yes, sir.
So see, I will add the value of this I to sum. So it becomes 1. And I increment the value of I with 1. That means it becomes 2. And I will add this I value again to sum. So now it becomes 1 plus 2, which is 3. And I'll increment the value of I. It becomes 3. So I will add the value of I to sum. So 3 plus 3, it becomes 6. And I'll increment the value of I with, and now I'll again add the value of I to sum. So now it becomes 10, and the value of I is 5. Again, I'll add it to sum. So it becomes 15, and I'll increment the value of I at a 6. So should I add the value of this 6 to sum? No, because my target is only to find out the numbers up to 5, not 6. So that means every time before adding the value of I to sum, I need to verify whether to add this number to sum or not. So I have to design one test condition such that whether to add the value of I to that sum or not. If that condition satisfies, I will add. If that condition doesn't satisfy, I will not add. Okay. So see how we can do that. Hash include stdio.h. So see here, I'll take a few variables like int I, so which starts with 1, n, I'll read the value of n from the user, and I'll take one more variable called sum, so which is 0. Okay. So I'll read the value of this input n from the user. Enter the value of n. The user will give a number n, so I'll read it into percentile d, comma ampersand n. Okay. So I'm reading the value of n, so which I have stored into this variable n. So now I have to write a while loop, so which I have to be iterate for some number of times. And what I will do inside this while loop. So what I'll do is I will add the value of this I with sum. That means I'll say sum plus I. And again, I'm storing the result into the same variable sum. I'm adding the value of I with sum. That is for 0, I'm adding 1. For 1, I'm adding 2. For 3, I'm adding 3. So where I'm keeping the result after adding, I am keeping in the same variable sum. So sum is equal to sum plus I, and I will also increment the value of I every time. Because from 1 it becomes 2, 2 it becomes 3, 4, 5, 6, I'm stopping. So how I'm stopping? By this test condition. So what test condition I'll write here? So when I'm repeating this and when I'm stopping this, I'm repeating this procedure when the value of I is less than or equal to n. Because I value is less than 5. That means 1 less than 5, 2 less than 5, 3, 4. I have to repeat it 5 also. That means equal to. So I'm writing the condition I less than or equal to n. And after coming out of this, I'm simply displaying the value of this. Sum of numbers is equal to something percentile d, So here I'm displaying the value of. So enter the value of n. Suppose if the value of n is 5, it displays sum of numbers is 15. You can give any number for n. So if the value of n is 10, it displays the sum of numbers up to 10. It is 55. So like that way you can display the numbers. Sorry, display the sum of all the numbers. Okay. So you can try for one more program. Instead of displaying the sum, you try to display. You read the value of some n from the user. You take the value of n. Suppose if n value is 20, you try to display all the numbers between 1 to 20, like 1 2 3 4 5 6 till 20. If the value of n is 100, the same program should display number from 1 to 100. Depending on the input user gives, you have to display numbers up to that point. So that is the task. So you try for writing that program. So if you have any doubts, you can just clarify now.
No, sir, no doubts.
Okay, if we don't have any doubts, so just we can leave. Okay.
Sir, can I leave?